Hey guys, this is going to be Leetcode 113. This is path sum 2. And then this is actually another example of a lot of the questions that I've done in the past, or I've gotten in the past, and I never kind of understood how to solve it. And I think it's a big issue when you're asked the question and you don't know how to solve it. And I don't know, for me it was actually a problem of just like not knowing if I'll ever figure out the solution, which is like a stupid way to think, but that's where I was at the time, and I would just kind of, put away these questions and never revisit them. But yeah, now I'm just a lot better at not doing that, and I feel like that you need to kind of come up with a different approach and just really spend some time figuring out how to solve the question. And a lot of times when you do something like that, you actually find out that it's a lot easier than you initially thought. So, yeah, that aside, this is Pat Sum 2. See, the idea is pretty simple, and that's always actually what I struggle with. I feel like I could conceptually understand what was going on and what needed to be done, but it was very difficult for me to put it into code. So diving into the question, we're given some sort of binary search tree. No, just a binary tree. This happened to be a BST so far. Now it's not, right? 11, 7, 2, 13, 4, and then 5, and 1. So I'm going to circle so it's easy to spot nodes. Right, it's the root node. We're given the root and the sum. And what we're tasked to do here is, starting from the root, find all paths to the leaf nodes, to all the leaf nodes that sum up to our sum. So if we start here, there's going to be many different paths: 5, 4, 11, 7, 5, 4, 11, 2, 5, 8, 13, 5, 8, 4, 5, 5, 8, 4, 5, 8, 4, 1. And what we want to do is just find all of the ones that sum up to 22, right? So if you do that here, you can go 5 plus 4 is 9, plus 11 is 20, plus 2 is 22, so that's 1. 5 plus 8 is 13, plus 13 is not 22. 5 plus 8 plus 4. 5 plus 8 is 13, plus 4 is 17, plus 5 is 22. So in this case, we would just return this pair and this pair, right? And then we want to return it as an array. So it would be an array of arrays of those numbers. So this looks like a recursive algorithm because we're going to constantly be going downward and checking if whatever path we're at is equal to our sum. And what we can do is, as we recurse down, we can update our sum, right? So we can, and then our condition for checking to return a path would be if the root's value is equal to the sum, and then we would just decrement the sum as we go down. So let's start coding. So we're gonna have like a main function that calls our helper function, but I'm gonna just define the helper function first. So I'll just call it traverse down, or just call it traverse. Takes in a root, and then a sum, right? And then I said we're going to return a path, or we're going to return a list that has all our paths in that list. And then each path we also need to consider as well. So let's do path, and then paths, right? Which would be our results. I guess we could just call that results. That might be easier to follow. So this is our helper function, and what we want to do is we need to do our stopping condition first, right? So we'll say if not root dot left and not root dot right, and I'm just gonna continue on from here, and root dot val, like I said before, is equal to the sum. Then what we want to do is we want to append that last value into our paths, right? Val, and then we want to append this entire path because we found that the root dot value is equal to our sum. So now we know that we have a path. So we can say res dot append path. And then otherwise, we need to continue down the iteration. So this is where you can, I don't know if you can do this in other languages, but I think it's easier to do in Python. So else, so what do we need to do here? So we're starting here, we want to go down to the 4, but we also might have like, or we have a right node here as well with the 8. So we need 5 and 4, and then 5 and 8 separately. So how do we do that? So we need to check first if root.left, if that even exists, right? And then if it does exist, what we want to do is recursively call this function, like so. So yeah, I don't need to do the self here. It's just all the Leetcode. You're always writing self, and it's always within classes. So we'll do traverse, we'll call it self, with root.left, since we're going left. And then for the sum, since we're checking 22, but when we go this way, we want to, our stopping condition is when root.val is equal to sum. So we need to update our sum, we need to decrement it by 5 in this first left iteration. So 22 minus 5, which is 17, right? So how do we get that? It's simply sum minus root.val. So updated sum is sum minus root.val. Alright, so that takes our sum, and then our path currently should be empty. It's an empty initially, so we'll do path plus root.val. Right, so this is our updated path, and then our results array stays the same. So path plus root.val simply means when you're at 5 first, doing the first iteration. So yeah, before, I guess when I did the 4, I should have, I forgot to do the step for the root, right? So going back up once, we'll start at the 5. If not root.left, no, it doesn't go, so it goes here. If root.left, which it has, then we have this, we're going to create a path which is initially empty. We're going to update our sum to be, oh yeah, no, I was right. Yeah, we're going to update our sum to be 17. And then our path, which was empty at first, we're going to add the value at root. Right, so this is P right now. And then the same thing for the right side as well. Verse, only thing that changes here is root.right. Everything else is the same. Right, so P is at 4, P is 5. At 8, P is also 5. And then we're going to recurse down. Right, so at 4, we're going, if not root.left, no. If root.left, yes. then we're going to call it iteratively again, or recursively again. And this time our sum is going to be minus 4. So 17 minus 4, 13. Right, so this s is 13 here now. And then path is going to be the current path plus root.val, which is now going to have 5 and 4. And then we haven't put anything into results yet. Same thing for our right traversal. Sum is minus root.val, which is 17 minus 8, which is 9. So s. Let's be consistent here. And then path, we're going to add our 8 into it. And then again, it's going to continue on 11. So just update the sum to be 2. Add 11 into our path. And then for our 8, so for our 8 we have two cases here now, right? The left and right. So we have the 13 and then we have the 14. So root.left, then we're going to, so we're branching out here. Right, we have 5, 8, and then now we have 5, 8, 13. That's 1. And then our sum is already greater than root.val. Or it's greater than, here, let's see. So we're at 9, and then we subtract the 13, so we're at negative 4 here. So I guess you could actually make a case where you can just break out if the sum is less than 0. But for simplicity's sake, you don't need to do that here. And then we have, on our right side, we branched out again to do, we still have the 5, 8 from our parent node, and then we added a 4 here, and then our sum was 4 minus 5, which is 5, right? S equals 5, S equals negative 4, and then you can see there that 5 is there. So when we go down one more step, if not, we're at 2 here, and then root.left, no, there's nothing. Root.right, there's nothing. Root.value equals the sum, because we've been constantly updating the sum, which is 2 now. So we'll append our last root node onto our path, right? 2. And then once we've appended that last value, we would append this entire path into our results array. And then we would do the same thing for the right side, 5, 8, 4, 5, and then we would append it to our paths. And then in the end, we would just we would call this helper function, and then we would get this array of arrays. That's this, 5, 8, 4, 5. Right. And then when you call the helper function, it would just look something like this. So let's say the find main takes in a root, and then a sum. Right, and then we have our results that we're storing our results in. That's just an empty array at first. And then we'll say traverse, same root, the sum, the path I said before is always going to be initialized to an empty array, and then results. And then once you call this, it's going to recursively call all these things that we ran through, and then it's going to populate our results array, and then you can just return res, and then that should give you this. Yep. All right. Thanks for watching.